Now we're going to apply this to business econ. C of x is a cost function, R of x is going to be a revenue function, and P of x is revenue minus cost, which is our profit function. So we have cost of production, C of x is a function of the number of units produced. Just kind of expanding on that. Marginal cost is marginal cost of production is the change in cost with respect to the level of production. Translate that into math symbols. It's a change in costs with respect to the level of production. What is that telling you? You want to recognize that that's telling us that it is dc dx. That is our derivative of the cost function. Derivative of cost function. What are the key things in here? We're talking about a change. It's a rate of change with respect to the level of production. That's when we say the derivative with respect to x. Let's take a look and see what's going on in here. Here's some graph. This will be C of x, our cost function here. And if I have at some value x and then I say x plus 1, here, what would this represent? C of x plus 1, C of x. That is our change in our cost. What would this horizontal be? That would be 1 because we're increasing by 1. Now let's take a look at the line. If I have 2 points on my line, what do you call this part? That would be my rise, and over here would be my run. And we're talking why is our C of x cost to produce x units of something no matter what it is. What is the cost of producing one more unit? What is the exact cost to produce one more unit? Well, that's what we did right here. That would be C of x plus 1 minus C of x. This is our delta x. Now, we have the slope of our line equals the derivative of the cost function, and this equals our rise over our run. And here's where it's important for this idea. What we're going to say right now is that these two values, now I drew it so you could clearly see on my paper, but if you kind of think about it, if x is close together, x and x plus 1, what can you say about the curve and the line? They're about the same. The rise is approximately equal to delta c. And our run is 1, so we're going to have delta c over 1 is equal to our dc dx. Or in other words, just dc dx is the approximation for our change in costs. So what is important about this is we'll use the derivative to find the slope. If delta x equals 1, and that's what we're using for this, then the slope is approximately equal to the cost of producing one more item, whatever that is. Let's take a look at an example of this. Suppose the weekly revenue in dollars from selling X custom-made office desk is R of X equals 2,000 times 1 minus 1 over X plus 1. Find the marginal revenue. Well, what does that marginal mean? We just went over it, an example of cost. This is applying the same thing. Our marginal revenue will be dr dx. How do I find that? Well, this 2,000 is a constant, so just leave it alone. Derivative of our 1 is 0, minus, how do we find the derivative of 1 over x plus 1? That's a quotient. So the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. Now we got to remember there's a negative here and a negative there, so what we end up having is 1. So we get 2,000 over x plus 1 quantity squared. Now find r of 20 minus r of 19 over 20 minus 19. some words I haven't used yet, but you should be thinking about is that this is a secant. This is an average rate of change. Let's see here. R of 20, we're going to plug it into this. And when we do so, we get 1904.76 minus 1900 all over 1. So that is $4.76. What does this mean? This is telling us that the revenue for producing one more desk after 19 have been made, so the additional revenue we're going to be making, is $4.76. Part C, I forgot to write down. What I want you to do is find R prime of 19, and I want you to compare it to the revenue for one more desk after 19 have been made. Made/sold here, because that's really for having our revenue. So R prime of 19, what we're going to do is just plug it into our equation that we found our marginal cost. We have 2,000 over 20 squared, and we get 5. So now what are we saying here? We're saying that this 5, we're going to compare this to our 476. We are using the slope of this curve, and our slope in this particular problem is going to be looking like this. And it says, if I have something just kind of sketching, and I'll call this 19, I'm using the slope at 19 to approximate this change. So at 19, the approximate change is $5 more revenue. The exact value was $4.76. They're pretty close. And that's basically it for marginal cost or marginal revenue.